So hello. Yeah, I'm really excited to be a part of this. Thanks so much for inviting me to present, Sean and Redwood Energy. And yeah, I'm happy to be kicking off. Um, Honored, in fact, to be kicking off such a great lineup of presentations.
Well, you're pretty amazing, and this project is pretty amazing. This is definitely the appropriate kickoff. Thank you for
Well, thank you.
start off for us.
Sure. So yeah, my name is Katie Ackerly. I'm an associate at David Baker Architects. We are, you can go to the next slide, a 30 designer person firm in San Francisco. We also have Oakland and offices in Oakland and Birmingham, Alabama. These are new, smaller offices. We have a growing presence in the Southeast US, which has been interesting. But yeah, for the last 35 years, David Baker, who's been the chief principal of the firm, has really made a name for himself doing design for mid-rise urban infill multifamily housing, both market rate and affordable. And you can go to the next slide. Housing, it's interesting. I have a background. I started off my career in energy efficiency policy and then got a degree in building science before getting my professional architecture degree. And so I find this sector really interesting because to me, it seems like, it might not be, at least new construction multifamily might not be the biggest piece of the pie, although existing multifamily is, and it sounds like we'll be hearing a little bit about that later, the Realize program, which are actually also play a small role in. But we do really new construction, and even though it might be a small piece of the pie, it really seems like it's kind of on the front lines of some of the challenges we're facing, and yet it's kind of it's a good place to go to see how kind of the industry typically works, right? Like these are not high profile, high budget projects. We like to design them with, like to imagine that they are, but our work is typically not as keyed in as we might be if we were an EHDD or someone who has a lot more ability to kind of key into the green building industry and partner with people who are also keyed in that way. And so I think the lessons learned I wanted to share just as a perspective of an architect is sort of both related to the technology, but also just in how knowledge is shared and multiple disciplines collaborate. Next, please. So I wanted to take a brief moment to talk about one project that we just completed. As of last week, it's 100% occupied. It's at Wiener Benner Plaza in Sunnyvale, 66 low-income family apartments. And it was a subject of a large epic project demonstrating 3 pilot installations of heat pump hot water systems. This one, you can go to the next slide, is a central system. So it has a recirculating loop, actually 2. So one plant serving the first 2 bars here, and another second plant serving that last bar. So central system like we typically see, but with Sandin heat pumps operating in series to feed large storage tanks. Working with Midpen Housing, who's the owner, and Nick Young at Association for Energy Affordability, who is our energy consultant on the project, and as well as sort of linked us into this epic project. So that's been really interesting process for us on our end. You can go to the next slide. Conceptually, the system is not particularly hard to understand, but our sector and industry is one that doesn't readily innovate. And so, for instance, we're working with mechanical designers who, if they're unfamiliar with a system, it really sets off alarm bells to doing literally anything new out of the ordinary. And so working with them, and then plumbing subs sometimes also at the contractor can be another obstacle. This particular design went through a couple of iterations as we were going through design. So that's just one function of being a part of the pilot. but also just going into operations, making sure the system is going online well and functioning properly is something that the research team is really in charge of. And just seeing that roll out and take place is interesting when we're trying to also kind of use this project and look ahead and see how we can use it to grow our advocacy to install similar systems and start pricing them out earlier on in projects. And so, I wanted to highlight this next slide because there was, obviously the grant money was pretty critical, I think, in making sure this design happened through design and construction phases. And it's something for us to keep in mind if we were to do this in the future. But also it's really, it's being driven by the research agenda. And so when it comes to, how this project lands with the owner, how it informs their perception of heat pump hot water systems, how they understand how it compares to the typical gas and solar thermal. We're kind of the ones kind of stepping in it to fill the gaps and talking to AEA. We had a sort of a debrief and decided just as a team how we could develop some tools to help both us and the owner kind of make sense of this system. So that was really interesting. I think a big piece of that is a systems operations narrative and diagram that works for us, but also is a little bit more of an intentional handoff to the operating team on site. Because once the researchers, will pack up their bags in about a year and report on the results, this system is going to be in the hands of the owner, and we want them to feel good about that. The other opportunity with this project that's really interesting is that we completed a very similar, almost identical project just a mile away with the exact same team, same consultant, same contractor, same owner. And so we're hoping to work with the owner to do a modest performance comparison there so that that can inform their design standards, hopefully. Next slide. So that was sort of our first experience with electrification. And now what I wanted to spend most of the time talking about was Coliseum Place, which is a project we're working on with Sean. It's in Oakland, California. Go to the next slide. It is 58 family apartments, very low income, the heart of East Oakland near the Oakland Coliseum. 20% designated for current homeless, formerly homeless, we refer to them, and 25% also people with mobility impairments. So it's, next slide, you can see it in its context. Sorry, go to the next slide, thanks. So it's in this kind of neighborhood with a lot of need, both for affordable housing and for increased density. And as a result, it's interesting, the owner came to us, so sorry, let me explain a little bit. It's situated not in the planned transit-oriented development next to Oakland BART station, but just adjacent to it at a formerly industrial site, which itself is just adjacent to this neighborhood that's very low-rise, single-family working class homes. Next slide. I forget what the next slide is. So the client came to us actually with this interest in doing, and there was something beyond LEED. They wanted to kind of advocate for something better. This was like 4 years ago. Doing zero net energy for a building this scale still seemed really out of reach. And the International Living Future Institute was launching a pilot program to look at how the Living Building Challenge might apply to affordable housing projects like this. And so we jumped on board in that pilot program, and that kind of opened the door to have a different conversation about this building than we would on another project. So a couple of things about it, just in terms of the design, just to spend a moment, is it's a pretty simple mass, double-loaded corridor. It steps back from the single-family neighborhood to the northeast. And typically on our projects usually like to create a welcoming entry and kind of a nice green open stair. We call them a green stair. I don't actually know why. We like to put greenery in them, maybe. Open circulation. In this particular project, we had an opportunity, just due to the site dimensions, to kind of maintain that slot all the way through. And opposite the stair is laundry, so common area, really accessible and kind of celebrated bike storage that hopefully actually gets used rather than kind of sticking the bike rooms in the garage. It also links green space, common open space, and the ground floor common areas. So we see this as kind of like a central active core, social, like a kind of a social environmental core. It kind of celebrates an International Living Future Institute's words, human-powered living. And kind of along that vein too, this was a very early diagram for the project, and RCD, Resources for Community Development, who's the client, went out for funding from the Affordable Housing and Sustainable Communities, so cap and trade funds. So it's the section of cap and trade that's allocated for affordable housing development. And a part of that program is actually a fair amount of collaboration with the city. This is a part I'm not actually that familiar with, but in terms of supporting new bike and transit routes. And I wasn't able to dig up exactly what this project's doing, but it's contributing actually in a pretty measurable way to transit and bike access in the surrounding neighborhood. So the whole idea is to reduce vehicle miles traveled, and that's just kind of an interesting aspect of this project. Next slide. So from just kind of the site response diagram, it also has a challenging southwest primary orientation, which seems to be actually pretty typical for us. We always have this orientation. It's tough to deal with. And so from early on, we conceived of a exterior sunscreen that actually was integrated with balconies that have since gotten removed, but the screen has survived. And we're doing this living building, so we're looking at this elevated PV canopy. In terms of just the envelope, it's actually pretty standard. I mean, we're not bending over backwards to do anything. We are just sort of on the better performance end of things. So we are using vinyl windows, R21 walls, and then we do tapered rigid insulation, mineral wool insulation. The Roxel has a roofing product that's tapered to provide the sloping, and so it provides actually a pretty high average R value. And then our kind of typical fiber cement rain screen. Next slide. So early on, I'm gonna check the time here. So this was what, like almost 4 years ago when this project actually kicked off, when they applied for funding in the first round and it was denied. But we were still a part of this LBC pilot project. And so we did an early stage design energy model, just with a little bit of a grant that we got from Enterprise Foundation to look at the feasibility of the energy pedal, which is net positive, actually, it's 105%, and the water pedal. So this was like a kind of a side project, and just as a side note, doing this kind of design energy modeling is not something we typically can afford. Title 24 compliance software has been the primary tool we use to make energy decisions, which is awful. Actually, I guess it's getting better now. It's until recently has been pretty inappropriate, and it's just basically hard to justify using analysis tools outside of that, and especially for affordable housing, or really anyone. I mean, no one sees a reason to either optimize for operating energy or comfort or anything you might use a kind of whole building benchmark model for. So this was a good opportunity to finally do that for one of our buildings. And so what you're seeing here is a number of iterations of just kind of a comparative look at what different measures would achieve in terms of energy reduction. Next slide.
And this is Sean. I want to reinforce, we had asked Dan Johnson to help us basically because there were so many different ways that the software didn't function, just to do corrections on spreadsheets essentially, or enter in values that weren't otherwise apparent. So yeah, continue.
Yeah, so Sean, no, you could probably appreciate that without that kind of diligence,
With
it would be a fairly useless tool, right?
We had to have 2 different teams of professionals just to make it work. Not really a great tool, unfortunately,
Right.
for what you're trying to do.
I think so. Integral Group did this early analysis, I think. I actually don't know what they were using, maybe IESVE or something. In any case, it's a fairly typical, right, Z&E feasibility analysis, sort of look at all these measures and combine them, trying to optimize the right package. And you could see where this analysis is sending us is towards a kind of build tight, ventilate right direction, near passive house air tightness, which, according to this analysis, shows it's probably the most bang for your buck, right, in terms of things you can do. And then heat pump water heating, which at the time was even more of a, oh, I don't know if we can afford that. I don't know if we can do that. And then my favorite was to really get there, was to do energy recovery ventilator, which is sort of linked to the air sealing, but a central air to water heat pump and hydronic heating and cooling. Next slide. Next. Thanks. That, what technologies for heating and cooling probably, isn't the biggest, didn't show the biggest difference. And so we that was clearly going to break the bank. So we didn't consider that. But this early analysis, this is just sort of how this analysis showed us going from a baseline building to one that almost got to the PV that the building could support. Next, please. So when we actually kicked off this project for real, when it got its money, it got its feet under it in the fall, this last fall, that analysis sort of started us with this base system, which is ductless mini splits in the apartments and individual HRVs in every apartment. And this is actually a pretty standard base system that we propose in our projects now. We've started using HRVs more in place of bath fans. There is some cost recovery there, so you're sort of switching out one piece of equipment for another. And then mini splits do tend to be more economical versus a ducted split system. But it's still a lot of little bits of equipment, and probably the primary downside, other than kind of installation costs and maintenance of tracking all these little pieces of equipment, is the maintenance schedule for filter replacements on the HRV. And this is a challenge, I guess. I kind of wanted to run through 3 different scenarios that we considered for this project after, Sean and our MEP came on board, because I think it kind of illustrates some of the unresolved issues in the continuing debate that we need to still be having about proper ventilation for these apartments. Next slide. So if we were to kind of cut out some of that equipment and upfront equipment, labor, and maintenance cost, we might go to a simpler package system. In this case, a VTAC that also offered some ducted distribution and infiltration, because there is to provide makeup air, because there is some research to show that just relying on the exterior wall acts as a decent filter, and there will be some that comes under the door to the corridor. We know that is a big issue, just by looking back at projects and seeing concerns about odors and drafts coming under the front door, and it's just something. That's kind of the chief downside, is you don't know where the air is coming from. But otherwise, it's a very simple, legible, easy to understand, and probably decently performing way to go. Next. We also considered a central approach to air delivery. Our mechanical engineer referred to this sort of a hybrid approach, where you're not delivering minimum outside air, you're upsizing the ductwork a little bit so that a central heat pump actually does provide some, does cover some of the heating loads, and the volume of air, even the cooling side, could be used for some sort of free cooling, kind of like an economizer idea for a multifamily building. But not with the complex zoning, right? So it would just have, each apartment would have control over a duct heater and no air conditioning. Next slide. So between the time when we kind of set out these three options, and I guess I should say that last one was, the whole idea was you would save on cost, the cost of installing heating and cooling equipment in every unit, and no air conditioning in particular. So that, as a side note, that didn't end up being a controversy for this project. Oftentimes we have a really hard time advocating for air conditioning. But in this case, we didn't. Everyone was sort of in agreement that heat waves are real and we need to provide air conditioning in Oakland. But it's just interesting to highlight that that really is not typically the case. So as I was saying, between the time when we selected those systems for comparison and the time we actually sat down and decided, this happened. The Campfire sent us elevated levels of particulates, very hazardous air. I don't think there was, it dipped below like an index of 180 for the entire 11 days. We have a particulate counter in my house, so I was sort of tracking it and refreshing purple air like 5 times a day. It really changed, I know, my thinking, and I think the thinking of folks on the client's team too. Just, you know, I know I was considering my 1-year-old and all the other 1-year-olds that, you know, with their families told to stay indoors, and kind of knowing that indoors is not that much better than outdoors when you have that level of hazard. Next. And so when we were looking at the criteria for selecting these systems, that idea of having filtered recirculating air became one of these resilience measures, that these are a reality, these smoke events as well as heat waves. And so air conditioning and filtered recirculated air is something we have to figure out how to provide without sort of adding a lot of complexity and expense. And so that was that kind of shifted the conversation a little bit too. In terms of cost, well, I guess I'll start with energy. So the first 3 bars are the systems I just mentioned, the ductless mini splits, which was our base and the best performing. And then a packaged VTAC in this case is the next bar. And then the central system was kind of like through the roof in terms of energy and cost. The cost actually seemed a little bit obscene. I'm not sure, a little dubious about some of the numbers, but anyway, that's what we got. And then we're also comparing that to more like typical market rate ducted split heat pump that we might usually see. And I also wanted to compare that to sort of the cheapest legal option that until recently, and even still in some projects, is where we sort of end up with. Even Title 24, this has not, in certain projects, this has not become out of bounds still.
But I want to give you a 4-minute warning.
4 minutes from the end, really?
Yeah. Well, it's 3 minutes now.
Hey, I
I'll give you an extra 3 or 4. Don't worry.
Okay, no, that's fine. Moving right along. So, so we ended up with kind of leaning more towards this. The package unit started looking pretty good, with the only downside being that it doesn't provide filtered supply air. Next. And so with the VTAC, actually, it's completely, it takes up like 9 square feet of an already very small living room. And so we're actually moving forward with a kind of smaller PTAC. So, you know, there are definitely downsides to all of the options, but in this case, we're really focusing on the theory, the hypothesis, right, that if you align, or that if you're focusing on kind of simple legible systems, cost, affordability, and maintenance, that in energy, your goals start to align. Next. And we're doing a simpler, we're pursuing a similar kind of hypothesis with hot water. And this is pretty interesting. This will be the first time we don't do a recirculating system in probably 25 years. The last building, at least I know of, had individual tank type water heaters in each apartment. In this case, Sean and RCD is working on a project that also does this kind of model of sharing these single family kind of style water heaters. In this case, we're trying to bank them into kind of mini plants that serve sort of groups of units across the building. Next.
And the thought is that they're probably lowest cost and highest efficiency at the same time.
Yes, yeah. And
like, it's supposed to be zero net energy building, so they're pursuing the most efficient and cost-effective strategy, hopefully. Sorry, that's just my editorial.
No, please, yeah. And yeah, we were kind of like, oh, where are they going to go? And then we sort of got excited about showcasing them even in this kind of central slot that I was talking about earlier. Next. So we've been going through a process with our plumbing designer of seeing how this would work. A kind of first take is a trunk and branch serving from each water heater serving the units that it's serving, generated a 2-minute wait time at the furthest lavatory because of how the kind of upstream branches needed to upsize pretty dramatically. Next. And so we're kind of still in the shredding phase. So we're working with Sean and our plumbing designer to pursue different options. One is maybe grouping fixtures more and working for more of a manifold to downsize those upstream pipes, which has already gotten us down to 1 minute. And then our plumbing designer on this project, bless her, is actually pretty open to doing more detailed pipe sizing calculations to get those pipe sizes down even more. Next. And so the big picture here is you can see this is where our current energy modeling is at. The overall footprint of the building is lower than the previous analysis was. But you can see also just how dramatically the recirc system plays into the overall energy budget. And what's exciting about this is, so City of Oakland is requiring electric vehicles for a certain percentage of spaces. And so you can see how those 6 spaces versus 100% of the parking garage would compare to our overall energy budget, the PV that the roof accommodates. Next. And just to kind of highlight that you could see, even though we didn't choose the most efficient HVAC system, it doesn't amount to more than like a 3 to 5% change in the overall total. Next. In terms of those design decisions that we made are kind of highlighted in yellow here, and they are represented by quite a significant savings if you also include deleting gas service to the building, which in this case was, honestly, we haven't seen that much money from doing this on this and the Edwina Benner project, but it is something. And then in addition to that, a 2015 utility allowance calculation suggested that we might recover over $500,000 from the owner being able to claim zero energy bills from their residents. So that's actually pretty amazing when you compare those sums of money to the big investments that this project would be making to go to zero, which is namely the exuberant PV structure on the roof. Next slide. And just in the last kind of minute or two, this is a talk about zero carbon, and even though the hot water and not doing on-site combustion is a huge part of that, I've been really fascinated to kind of see an order of magnitude how some of these efficiency measures are stacking up against some measures that you can apply in embodied carbon, the material side. And again, we have an amazing team here. We have very kind of eager and supportive structural engineer as well as plumbing. In this case, he is looking at different options for reducing carbon and has determined that doing cement replacement and high percentages for the mat slab, which is easier to accommodate than other parts of the structure, can represent kind of a significant reduction in global warming potential. And if you look out 10 years, which is sort of like our pencils down moment, you can start to see that this isn't math. I mean, I did my best here. I'm sure it requires a little bit more scrutiny, but you can see the kind of order of magnitude of that reduction of just replacing, doing more cement replacement in just that concrete podium, how that compares to the savings measures that we were able to achieve on the efficiency side, namely the recirc. So that's just sort of food for thought. And next, moving forward, we're kind of interested in it. It really demonstrates more of an approach than a solution, that with simple tools and kind of intuitive ways of thinking about it, as long as you kind of stay focused on that, kind of the possibility of those opportunities. Maybe the steel structure is not doing us any favors from, like maybe we could still roof mount a lot of the PV, eliminate all the, embodied carbon caught up in the steel structure as well, cut cost. And again, the theory is that all of these things can start to align if you sort of think about it.
Now with that, Katie.
Yeah, that's it. That's the last one. Thank you.
Now, yay, Katie!
Yay, thanks.
So you showed us something that was like the solar array is going to replace the carbon in the foundation after about 3 years, since it's going to be zero net energy-ish.
Yeah.
And that's awesome. I love that carbon analysis of the cement. I saw those emails coming in this weekend. Brilliant. Now, we should transition to Martha Brooke, who's going to show one last thought to add, is that like your emphasis here on all the different ways we could save energy. I think you showed a graph showing that we have like only 80% of the roof filled, even though it's 6 stories tall. Now that's, and then we have space for cars now, like for electric cars on this 6-story tall building. In just a half an hour, we're going to have a wall-mounted PV presentation and all sorts of different interesting applications of PV that can help us go even higher.
Yeah, for instance, if we can only keep one of the 2 exuberant screens in the project, then maybe we can mount PV on the screen instead of the.
Yeah. Yay. Okay.
So